Hi class, today we're working on solving quadratic equations by using square roots. Our objective is to be able to use that information and apply it in solving the problems. So some quadratic equations cannot be easily solved by factoring. Okay, so square roots instead could be used to solve some of these. Okay, so recall that when you find the square root of a number, okay, so there are always two values, a positive and a negative one. So by looking at the property in front of us to solve a quadratic equation, okay, notice how we have an equation which is x squared equal to a, where to solve for x, you get the square of, or the square root of both sides. And we remember, whenever you get the square root of a value, there are two possible answers, a positive and a negative one. So that's essentially what we're going to try and work on. But in addition to that, I want to put emphasis on when exactly you're using the square root property. You use the square root property if and when. Okay, if and when, notice this, you only have one variable which is in the second degree, at least for solving quadratic equations. Notice how it's just x squared. There are no x terms or x cubes, just x squared and a number. That's the only time you use the square root property, all right? So if I were to give you an equation such as, for example, x squared plus 3x equal to 0, you cannot use the square root property because there is an x term that you can see here. So this can be solved probably by factoring. Clear? Okay, so let's go ahead and actually try a few problems out. We're instructed to solve by using square roots. Let's look at the following. To solve the square root of part A, we take the square root of each side of your equation like so. Okay, get the square root. Remembering that whenever you get the square root, there are two possible answers. We said that it could be positive or negative. And we know that the square root of 16, which is a perfect number, will become 4. So there are actually two answers, a positive 4 or a negative 4. So that's actually your answer right there. Okay, or you can use the written form with a plus minus 4 with the value, and that's okay. They mean the same thing. Okay, all right, so let's try out part B. So again, we're solving for x. So we need to undo the square, and in order to undo the square, okay, to eliminate it, you have to get the square root of both sides of the equation, making sure it's balanced. Now, here's the thing. Here's the problem. When you try and get the square root of a negative number, it's not really possible. Because right now, we're focused on solving for zeros that are real. But because we're getting the square root of a negative number here, in this specific example, we're not able to do so because the roots or the zeros of this value right here will become imaginary. So instead, we say there are no real, okay, because they're imaginary. So there are no real solutions. And this is all you have to put down, okay? Again, you only say that there are no real solutions if and when you're finding the square root of a negative number. So let's go ahead and move on to the next page. Okay, take a look at the following. I have 3 examples. Feel free to pause the video at any point right now so you can practice on the following first. All right, so let's continue. So let's look at the answers to the following. So use square roots to solve the answer. And again, you can check by plugging in the value that you got, right? Okay, so first of all, you get the square root of each side to eliminate the square. And when you do that, you know that there are two possible answers, positive and negative. And the square root of 21 will become 11, correct. So your answer should say a plus minus 11. All right, let's look at the next one. Okay, let's get the square root of x squared equal to 0 for each side, okay? But remembering that this is a 0. So when you find the square root of 0, it becomes a positive and negative 0, which does not make sense because there should not be any sign on there written down. So you can just stop and say, okay, well, the square root of 0 is still 0 anyway, so just x equals 0 is enough. All right, next, for the last one, we're going to try and get the square root, so try to remember. what happens if you're trying to get the square root of a negative number, right? So to find the square root of a negative number is not possible, okay? Because the zeros are going to be imaginary. Instead, we say that there are no real solutions. Okay, so hopefully you've been able to check the answers that you got and compare them with what we have here. All right, let's go to the next page. All right, so right now, we're going to look at a different set of examples. Sometimes, right, sometimes it's necessary to isolate the variable. Okay, so remembering at the beginning of the video, we mentioned that the only time you can use the square root method is if and when you only have an x squared term, and there are no other x variables available, or any variable for that matter. And you'll have to do some inverse operations to make sure you isolate the x squared term before you can actually apply the square root property. So let's take a look at the following. For letter A right here, the first example, in order to isolate, we said we need to isolate x squared, we need to eliminate positive 5 over here. So ask yourself, what do you need to make alone, or which term should be alone? So we say this first term should be alone, so let's leave it right there. But how can you eliminate the positive 5 right next to it, okay? Yes, you're right, we need to subtract it. So then if it's subtracting 5 here, you need to subtract 5 on the other side of the equation. And so x squared is actually equal to 0. All right, and then of course you continue and proceed to get the square roots, since now you've isolated the x squared term. And as we did previously, we found that the square root of 0 will remain 0 anyway. Okay, all right, let's try the next example. So right now we have 4x squared minus 25, but we do want to make sure that the x squared term is alone. So we need to isolate this. Let's try and keep this by itself. In order to do that, okay, yep, you want to add positive 25 to each side of your equation. So I'll do 4x squared is actually equal to positive 25. However, we're not yet done. Remember, the objective was to make sure that the x squared term is by itself without other leading coefficients other than 1. So this means we need to divide the entire equation by 4. We need to make sure that this is just 1x squared. Okay, so in order to do that, we needed to divide by 4. So x squared is actually equal to 25 over 4. And now that your x squared term is by itself with a leading coefficient of 1, you can go ahead and get your square root values. And luckily, right, these are perfect square values. So x is actually equal to the positive and negative values of 5 over 2, correct. And there are two answers, a positive version of 5 halves and a negative one of 5 halves. And now we're ready to do the next example. All right, so for the third one, okay, notice how we have a parenthesis that is being squared on the left-hand side. And in order for us to get to the x term, we know that we need to eliminate the square first, okay? Unless you prefer to expand this, meaning you want to apply your FOIL method and expand it and maybe solve by a different way. For now, let's focus on using square roots. So in order to isolate the x term, we need to remove the square. And we can do that by using the square root method. So let's get the square root of each side of the equation. What this does is it eliminates the power. So we have x plus 2 equal to the square root of 9, remembering that now we're actually getting the square root. So the square root of 9 is 3. However, because we're looking for a square root, it needs to be a positive 3 or a negative 3. All right, so Mrs. Flores, how do we go about continuing this? There are two signs that looks very different. So here's what you want to do. This just tells you that there are two possible answers. One, where you have x plus 2 equal to the negative value of 3. And the other one, x plus 2, which will be equal to the positive value of 3. Okay, so notice how we split the positive and negative 3 plus minus 3 into the negative and the positive versions. So this really shows us that there are actually two answers. So let's go ahead and simplify further. So negative 3 and subtracting 2 more will give you negative 5. On the other hand, so 3 subtracting 2 will give you a 1. So really there are two zeros and they're going to be negative 5 and positive 1. all right? So at times you will have to do this. You will have to do or create the two cases and actually find the two possible answers, all right? So on the next page, you'll have an opportunity to try two examples out. So go ahead and pause the video at this point. Give yourself time to work on the following problems. All right, so in the first example, you want to make sure you isolate the x squared term, remember? Okay, so let's go ahead and move 49 over. That means we're subtracting 49, like so. And then we'll have to divide it by 100, all right? Because we want to make sure that we're just using the x squared term. And when you do that, we'll come up with a negative 49 over 100. And what do you guys remember about solving for the square root, specifically for the square root of a negative number? You're right, it becomes imaginary. So we say that this problem right here has no real solutions. They will become imaginary. And we'll discuss further about imaginary numbers and their values once we step into the Algebra 2 classes, all right? Okay, next one, 2b. Okay, so now you have a square, which is outside the parentheses. And in order to get to x, we need to get the square root so we can undo the power. So if we try and do that, we have to get the square root of 16 as well, which we know will become a 4. And on the left-hand side, we're eliminating the power, all right? So we have x minus 5 equal to the positive and negative 4 value, just like so. And again, we end up with two possible scenarios here, where you have a positive 4 and a negative 4. So again, you want to go ahead and create the two cases, really, because you're expecting two answers. All right, something like that, where one is equal to the positive 4 value and the other is equal to negative 4. And you go ahead and proceed solving for x. On the left-hand side, we find that x is 9, and then on the right-hand side, x will be positive 1. And those are actually the answers to the problem. So if you want to check your answer, you take one of the values, plug them back in. For example, let's take the value 9. If you plug 9 back in, 9 minus 5 is 4. And if you squared that number, it should equal to 16. In this case, it's correct. Now go ahead and try positive 1. If you plugged in positive 1, so this becomes 1 minus 5, which is negative 4. However, because you're squaring this, it becomes positive 16, which is equal to what we wanted. So that's how you know you did the steps correctly and that your answer is correct. Okay? Okay, let's go forward. Now, on this page, we're going to work on a few examples where you don't really have a perfect square value. Okay, what does that mean? So some of the values that we're going to find eventually are going to be irrational numbers, okay? Non-repeating, non-terminating values. So what we can do instead is we can provide an approximate value. So for example, solve the equation given and round to the nearest hundredth, okay, hundredth, so 2 decimal places. So in order to do that, we'll make sure that first of all, we can use the square root method because we are only seeing a single x squared term and there are no other variables. All right, so let's copy the equation first, like so. And our objective is to make sure we can isolate the x squared, right? So we need to eliminate 80 here and bring it over to the other side. And so we get negative 80 is equal to negative 2x squared. At this point, you still have a negative 2 with the x squared. So in order to eliminate negative 2, let's divide the equation by negative 2. So then we get a positive 40 equal to x squared. Now in your calculators, you can enter this information in and find the square root of 40. Eventually, we're going to get two possible answers, a positive and a negative value. Okay, so remember that we have to round to the nearest hundredth. Okay, we're going to get a positive and negative 6.32. Okay, so in your calculators, you would have seen something like 6.324555 and so on and so forth, right? But we're only rounding to the nearest hundredth per the instruction. So we stop at this value right here, checking if the next value will be helping us round up or stay at the same value. In this case, it's just 4. So then we say, okay, these are the answers to the given problem. There are two possible answers, a positive and negative value. So on the next page, you'll have an opportunity to try these out. I have 3 examples for you to work on. Feel free to pause the video at this time and practice. All right, let's look at the following. In 3a, you want to make sure you isolate the x squared. So the easiest would be to move the x squared instead of the 90. And that's exactly what we did here. All right, and then we go ahead and proceed to get the square root, where of course 90 is not a perfect square. So then we'll round to the nearest hundredth. And when you do that, there should be 2 possible answers, a positive and negative 9.49. All right, good job on that one. On the other hand, for 3b, our equation says it's 2x squared minus 64 equal to 0. So we need to isolate the x squared term. So first step is to move 64 over like so. And afterwards, because we need x squared by itself with a leading coefficient of 1, we need to divide the equation by 2. And so we come up with x squared equal to 32. And now we're ready to get the square roots, remembering again that you have a positive and negative value, but this time it will be plus and minus 5.66. Okay, so remembering you're rounding to the nearest hundredth. And of course for 3c, okay, we need to isolate the x squared term. And when we do that, we're moving negative, or we're going to create a negative 45. And then we proceed to get the square roots. However, you remember that, oh wait, I cannot exactly get a real solution for the square root of a negative number. So instead, I would go ahead and say that there are no real solutions, all right? So this is how we're applying all the information we're working on at this point. Okay, so let's go ahead and go forward. I have here a very short word problem and application. So a zookeeper is trying to buy fencing to enclose a pen. Now the pen is an isosceles triangle, right triangle, so meaning 2 of the side lengths of the triangle, see those marked with X, those are the same measures, and there is already a fence on the 3rd side, so that we don't even need to worry about this side, okay? Obviously it's fenced already. Instead, what we know is we're going to look for the fencing that needs to be purchased based on the 2 unknown side lengths. Meanwhile, we were informed that the area of the pen, this whole area right here, is 4,500 square feet. So how many feet of fencing should be purchased? So let's start by identifying a few things. Because you're looking for the measures and you have the information about the area, we know that we will be using the area for a triangle, which is 1/2 multiplied by its base and its height. Okay, so from this information, we're going to go ahead and plug in what we know already. We were informed that the area is at 4,500 and that the base and the height will be the x values. Those will be the legs of your triangle, yes? All right. And we're going to go ahead and simplify this, 4,500 equal to 1/2 x squared. All right, so notice how I'm doing the steps carefully. I do not need to rush. I'm taking my time, making sure I'm producing and conducting the steps correctly. From here, my objective is to isolate the x squared term. However, I cannot because there's the 1/2. So how can we eliminate the 1/2? Yes, you have to multiply the entire equation by 2, or both sides of the equation by 2. In this way, we can eliminate the fraction 1/2. So 4,500 squared, or times 2 rather, is at 9,000 equal to x squared. And at this point, you're able to use your square root method. So let's go ahead and do that. So let's find the square root of 9,000. So again, if you do this in your calculators will not show you the signs, the 2 signs. Instead, it'll just give you a number. So the square root of 9,000 must be rounded to the nearest feet or foot is at 94.86868. So we're rounding. Let's go ahead and round this now to the nearest foot. Okay, so this will be, when rounded, is at 95 feet, right? Positive, negative 95. Okay, but here's the thing. We're working on an actual application where you're actually looking for a measure of a fence. Can you imagine going to a hardware store where you have to say these numbers? Obviously, they won't understand you. So you need to be able to analyze what information are you providing. So then we say that really, because we're looking for the length of a fence, we only take the positive value. So we say we need to purchase, or this zookeeper needs to purchase 95 feet of fencing. All right, so that's it. Being very specific to answer the problem. We can't just say positive, negative 95, because that's not relevant to what we're trying to find at this point, okay? All right, so on the next page, you'll have another opportunity to apply the square root method to another problem. Let's take a look. Okay, so right here, a house is on a lot, which is shaped like a trapezoid. Pretty cool. The solid lines show the boundaries, all right? So these are the edges of the house. Now, X represents the width of the front yard. So this is the front, pretty cool. I mean, your house is narrow from the beginning and then it gets wider. Okay, that's pretty interesting. Find the width of the front yard, given that the area is 6,000 square feet. Okay, so remembering we have a few information we can use. The area is at 6,000 feet. Okay, we can highlight that. And the X represents the width of the front yard. All right, let's go forward. We're going to round to the nearest foot, okay, where we are also given some tips right here. That the area of a trapezoid given is that you get 1/2 of the height and multiply it by the sum of the base of the two bases. What are the two bases? It's the top and the bottom sides. Okay, so let's look at this. Now that we have this information, we're going to go ahead and plug in what we know. All right, so let's take a look. We're going to plug in 6,000 as the area that was given to us, and multiplying 1/2 by the height, which in this case is 2x right here, okay? And then of course we need the sum of the two bases, the two edges. So we're going to add 2x and x like so, okay? So I prefer to do my problem step by step. So let me show you so it's not mixed up altogether. Then again, you have that option to do so. I'm just showing step by step right now, okay? All right, so first I want to simplify the expression in the parentheses. So I'll produce a 3x at the end. And then I'll go ahead and proceed to multiply the two variables on the right-hand side. So I'll have 1/2 being multiplied by 6x squared, okay? All right, so I'm doing it step by step. So right now I'll go ahead and simplify further because now I can easily multiply these two terms into 3x squared. And now that we're almost done, we're almost at the point where we can use your square root method. We are now able to divide the expression by 3, thus resulting in 2,000, right? 2,000 equal to the square root, or 2,000 equal to x squared. And then of course we need to get the square root of each side, okay? Again, remembering that 2,000 is not a perfect square, so we will have to use our calculators to help us identify this. And again, because we're using the square root method, you must make sure to show the positive and negative values. In this case, rounded to the nearest foot, okay, the square root of 2,000 is positive, negative 45. However, going back to the problem, we're looking for the width of the front yard right here. This is the width. We're looking for this. And if we're looking for the width, we can't really use a negative value. So instead, we could say that the width is actually 45 feet. Okay, so this is where you have to apply your analysis and actually go back to the problem and find out what you're looking for. So at this point, you've been able to use square roots, okay, or identifying square roots to solve problems. And also, you've been able to use the square root method in order to solve problems such as these, where you're involving the area of a specific shape. Okay, so I'll stop for now. Please take note of any questions that may come up, and we can discuss them further on our next meeting. Bye for now. See you soon.